So this session is all on binary shifting. So hopefully you already understand how binary works. We'll just do a quick recap on binary and then we'll move on to understanding about how shifting works. So binary shifting is literally, as the name suggests, we're moving the values, the binary values, either left or right. So just a quick recap. So remember that a bit is a binary digit. It's either a 1 or a 0. There are 8 bits in a byte, and computers use bytes to store data. So 8 bits would be used to store a byte of data. So when we move left or right, that will be defined by the question that you're given in the exam. So if you're told to move left, they'll say how many places to move to the left, or if you're asked to move right or shift the values, the binary values left or right, it will tell you how many places to go. Something to keep in mind is that when you go outside of the block of 8, those bits of data are lost forever, but we'll come on to that as we look into it in a bit more detail. So there are key bits of information we need to remember as we go through this. So a byte is a unit of data that is 8 binary digits long. There's 8 bits in a byte. The smallest amount of addressable memory is a byte as well. So with binary shifting, we can multiply or divide. So computers aren't very good at doing multiplication because they're too slow for the CPU to process. So when we shift bits in a register to the left or right, it's a lot faster for it to do that. So as the CPU uses binary, you can replace multiplication and division by shifting bits if they're to the power of 2. Binary shifts allow us to move all the bits stored in a register on the processor either to left or right. If we move the bits to left, then it's a left shift. If we move to the bits to the right, then it's a right shift to data. So when we move to the left, that's what we called multiplication. So if we had a value, for example, if we had 22 and we times it by 100, that would be 22 10 to the power of 2, so it would be 2200. It similarly works with binary as well. So when we multiply by 2, we're multiplying by the power of 2. So if we do 2 to the power of 2, that's 2 places to the left. If we do 2 to the power of 3, that's shifting the binary values to the left by 3 places. And if it's 2 to the power of 4, that'll be shifting 4 places to the left. So if we had an 8-bit number, so we had 00101000, and we shifted that by 2 bits, it would then become 0010100. So all we're doing is shifting those values to the left. So here we go. We're moving the 1 2 places up, we're moving 0 2 places up, the 1 2 places up, 0 2 places up, 0 2 places up, and 0 2 places up, and then those 2 on the end, they're lost forever. So all we're doing is just moving those 1s 2 places, okay, and then any spaces you have are just filled with zeros, and that's what it is. So we're just infilling with zeros. So when we divide, we are dividing the number by the power of 2. So all we're doing is shifting down. Each place is dividing by the power of 2. So if we had 00101000 and we wanted to shift it by 3 places, we'd have our original value, and then all we're doing is moving those values down 3 places. So the 0 goes down, the 0 goes down 3 places, the 1 moves down 3 places, the 0 moves down 3 places, the 1 moves down 3 places, and then the rest of it is infilled with zeros. Okay, so it's fairly straightforward if you just think about moving the values down your grid, and then anything that's disappeared or any spaces that remain, you just put a 0 in its place. So why do we bother shifting? So shifting, if we shift to a value to the left, all we're doing is shifting our binary value. So if you think about this, so on this first row here, we've got 0 0 0 0, and then when we shift that to the left, it doubles in its value. So we've gone from 1 to 2, we shift another value along, we've then doubled to the power, so 2 times 2 is 4, and we've gone to 4, and then we've got 2 to the power of 4, which would be 2 times 4, which is 8, and then we're into the 8 value here. Okay, so every time we shift a value to the left, it doubles or multiplies by 2. And then obviously if we shift to the right, we are divided by 2 as well. So here we've got another set of values. So we've got 0, 0, 0, 1, 0, 1, 0, 1, and that's 20, equivalent of 20 in denary. And then if we shift it down one more row, that goes down to 10 because you've got an 8 and a 2. And if we shift it down another place, it becomes 5. So it's a 4 and a 1 is 5. And then when we shift down the next value, because we can't half 5, we go to the smallest, we round down to the smallest value, which then becomes 2, and that becomes the value of 2. Okay, so we lose some form of accuracy when we do binary shifting. So we can't represent a half number in binary, we can only round down to the smallest value. So you'll notice in the examples we do, we start to lose some of the data, some of the accuracy of the data. So the impact of binary shifting is each shift to the left is a multiple of 2. So 2 shifts to the left will be 2 times 2 or 4. This tells us that 2 shifts to the left is the same as multiplying by 4. 3 shifts to the left is 2 times 2 times 2 or 8. So this is the same as multiplying by 8. So if we had a question like this that says explain how a binary number can be multiplied by 8 by shifting the bits. So something to keep in mind in the exam when you get these answers, questions. Make sure you remember to explain where the bits should move, by how many places and why. You also need to explain where the zeros need to be inserted. So here our answer would be 8 is equivalent to 2 to the power of 3. So all the bits should be moved 3 places to the left. Zeros should be inserted into 3 rightmost positions. Okay, so we get 1 mark for our demonstrating that we understand that 8 is equivalent to 2 to the power of 3, and then it'll be moved 3 places down, and then we understand that any spaces would be infilled with zeros. So that's just a good example to get your head around. The next one says complete a 3-place right shift on the binary number 10110100. Explain why there is a loss in precision. So the original number, and then when we results of our right shift, as we see, we've moved 1, 2, 3 places down. So this is going 1, 2, 3 down. This is going 1, 2, 3 down. 1, 2, 3 down. 1, 2, 3 down, and 1, 2, 3 down. So what we've got here then is we can say that this original line was the equivalent to 180. Okay, and then we're going to divide that by 8 because it's 2 times 2 times 2, or 2 to the power of 3, which is 8. That would give us 22.5. And then we shift it down, and then when we convert it, it's the equivalent of 22. So this is 16 plus 4 plus 2. So 16 plus 4 plus 2, which is actually less than 22.5. So we've actually lost half, 0.5. And once again, that's an example of where some precision is lost when we do binary shifting. So the next question is multiply 000111110, which is 30, by 2 to the power of 2. So we're going to shift the values to the left, aren't we? So if we look here, this value goes to 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 here, and this value goes to here. And then we just infilled the back part with some zeros. So just shifting those values along by 2 places. So then our answer becomes 0, 1, 1, 1, 1, 0, 0, 0, 0, and that will be enough to give us the marks. So you can always double check your answers as well, so by converting it to denary. So we know that 0, 0, 0, 1, 1, 1, 1, 1 is 13 denary, and then 2 to the power of 2 is 4. The answer would then be 30 times 4, which is 120, and then the answer we got was 0, 1, 1, 1, 0, 0, which is 64 plus 32 plus 16 plus 8, which is 120. So therefore we've got the right answer. So the next one is divide 10 1111 0, 0, 0, 2 to the power of 3. Okay, so it's asking us to shift the digits by 3 places down to the left. So here we go. So that's our first one. So 1, 2, 3 places, and the next one, and the next one, and next one. And then just remember here that we're infilling these with zeros where the spaces are left. So therefore our answer becomes 0, 0, 0, 1, 0, 1, 1, 1, 1. Okay, so once again we can check that by doing a simple bit of maths. So our original value was 184, and then 2 to the power of 3 is 8. So 184 divided by 8 is 23. So therefore we can check our answer. We were left with 0, 0, 0, 1, 0, 1, 1, 1. So 16 plus 4 plus 2 plus 1 is 23, and we have the right answer. Okay. Another example, just to quickly get your head around. So complete a two-place left shift on the binary number 0, 0, 0, 1, 0, 1, 0, 0. So this is equal to 16 plus 4 is 20. And then when we shift it down two places, so we're going 1, 2, 1, 2, and the rest is zeros, which is infilling those. So original value is equal to 20. After the shift, we're equal to 80. So 2 times 2 is 40. 40 times 2 is 80. And we get our answer. Okay. One more. So complete a three-place right shift on the binary number 10, 0, 0, 1, 0, 0, 0. So our original value is 136. We've got 128 plus 8, which is 136. So after the shift, we're down to 16 plus 1, which is 17. So 136 divided by 8, so it's 8 because we are 2 to the power of 3, equals 17. Okay, so once again, we're double checking our answers just by doing a simple bit of conversion, and then we get the answers. Okay, so one more thing to show you before I stop, and that is this is the 2018 past exam question. So the first thing said complete a two-place right shift on the binary number 11001011. So all you'd have to do to get the mark is just demonstrate your shift. Okay, so just shifting the values down two places, and that's all they're looking for, and that's enough just to get you your single mark. So not a high mark question, but just showing your knowledge. The marks then come in the second part. So it says explain the effect of performing a two-place right shift on the binary number 11001011. So it's the same number in the first part of the question. So all they want you to do is to demonstrate that you understand that when you move to the right, that you're dividing the value. So here we had 128 plus 64 plus 16 plus 1 plus 1. Okay, and then when we move it down, all we're doing, because we're moving two places down, we're dividing it by 4, aren't we? So the original value is 203 in denary. The binary value after the shift is 50. Therefore the number has been divided by 4, and there has been a loss of accuracy. So when we divide 203 by 4, it rounds it down to 50. When the shift takes place, the bits are moved on the right are removed. Okay, so just remember this here. So these are infilled with zeros, and that's basically what they're looking for you to demonstrate. So demonstrating you understand that when you move to the right, it's division, and if it was the other way around, when you move to the left, that will be multiplication. So really the examiner is just wanting you to demonstrate that you understand how that works. Hopefully that's been useful for you. Tune in for the next one.